Hello everyone, welcome to week 2 of the data engineering workshop, and today we're gonna look and deploy some machine learning models with Streamlit and Gradio. Before we start, first we would like to recap what we studied in the previous workshop because I can see there are some new folks. So in the last workshop, we looked at these two Python libraries, Streamlit and Gradio, which are used for developing machine learning demos. And the main distinction was based on these four aspects of purpose, ease of use, flexibility, and how difficult it's to learn them. And in the last workshop, we looked at how can you make a small college fest registration website or a data explorer, but we didn't really look at how to develop or deploy machine learning models after training. Let's say you are training a machine learning model and it's sitting in your Jupyter notebook. So now today we will learn how to put that model out of your Jupyter notebook and make a small demo based on that model. And first we will look at Streamlit because like we discussed in the last workshop, Streamlit is very like it's ideal for rapid prototyping of your models. Like you can quickly develop a demo, whereas Gradio is little more sophisticated. And it's especially like specifically designed for having deep learning models, and there are some pros and cons that for Streamlit you have to, like if you're running on an external server, you have to tunnel your IP so that others can use it, but Gradio has this automatic function built in inside so that you don't really need to showcase your model by using some external tools, and it will automatically do it for you. And in today's agenda, we're gonna look at 4 applications. So the first 2 applications are from computer vision that would be based on mostly images. And in the next half, we will look at NLP applications. There we will first look at text-based application where we will be detecting like it's like a multi-label classification where you detect emotion in the text, and the next one would be converting your voice or a song to a text, or it's like extracting what's being read or said in the audio file. So let's go back to the Collab notebook, and if you guys are ready, can you give a thumbs up if you are ready with this Collab notebook? Please let me know if you have any questions. So first we'll start with Streamlit, and so first few cells would basically just uh, deploy your Streamlit server, and once we have the server running, like for example, this is my server, it's running on a tunneled IP on Cloudflare, which says my first ML model deployment, and other than that, it does nothing. So we will build upon this. And so once you go through this first cell, install Streamlit and the libraries required to tunnel it. After that, you have to launch this Cloudflare file, which will tunnel your local host to an IP. And then once you get that IP running, you can keep running till cell number 5, which says that Streamlit run app.py, which means that whatever is inside your app.py file, you want to show it on your server. And once you click this link, you should be able to see your first Streamlit app. Please let me know. Yeah. Yeah. Once you have reached till this stage, please let me know.
Shashank, can you share the Google Colab link in the
Yeah,
chat?
sure. So this is the GitHub uh, page for today's workshop. If you go here, this is today's date, and then if you click here, I'll put this in the chat. I think that's the notebook hosted on GitHub, but I'll provide a link, and if you click that, you will directly go to Colab so that everyone's on the same page. Okay. Thanks, guys. So let's go and build our first application. So without going into like specific details of like how this model works, because today what we're going to focus on starts after you have developed your model. So let's say you attend the other workshops by DSI, where you get to learn all the machine learning and deep learning stuff. And now you want to make a prototype of your deep learning app. So today we're going to focus on mostly those steps. And now we would like to build a image classifier with this Inception V3 model, which is a kind of a very like state-of-the-art model for classifying images. And the task, like for what's image classification? It's just that like given an image, the model it should be able to classify that it's a links, or we'll see other examples after some time. So let's go and run the cell after the links photo. So here what we are doing is we are loading this Inception V3 model where the weights are from ImageNet. So this model is already trained. And then we define two functions where first we load the image and use the model to predict, and then convert those predictions into text so that we can see on our app that how it works. Yeah, so once I have overwritten the app.py and go back here, so let's run this cell and quickly go ahead and check on our app.py. And now it says that instead of just the title, we have changed the source file, and the app knows that the code behind is changed. So we can go and refresh it. And once we refresh, it will take some time, and now it says image classification with Inception V3. And now it says upload an image and the model will classify it into top 10 categories. So if you, yes, that's right. So if you go here and go up, scroll up, and then the images folder on the data engineering, I have put some sample images. So you can try to download these or maybe try your own image. So since I have already downloaded these images, we can go here and let's try one. So now we have this browse files, and then we go to, let's say, let's try the first example, links. We choose the links image, select it, and then now the model starts to predict. So it loads the image just to verify that you have uploaded the correct image, and now you see the predictions that the model is saying it's a links with a probability of 0.93. One sec. Okay, cool. I will make the font bigger. Is it okay, Meg, right now? Oh, it's too big. Is it okay, guys? People on Zoom? Cool. Yeah, so what we did in this app is that we first called the model from, it's a pre-trained model. Then we have our classify image code, which says take an image, convert it to a NumPy array, and now pre-process it. And what pre-process is doing is that any shape or any dimension you put into the model, it will pre-process it to a specified dimension which are required by this Inception V3 model. And then the image, now it's instead of the image, it's now converted into a NumPy matrix, and it's passed into this model. The model gives its predictions, and now we predict the top 10. Since ImageNet the problem was, so this model was developed on 1,000 category classifiers. So we are not interested in like all the 1,000. We are just interested in what are the top 10 classes for where an image can be classified. Now, once we have, so this main code is for running Streamlit, that you have the title and then whatever text you want to display. And this st.file uploader is specifically to have user input to your app. And once you have the output from your classify image, the outputs can be displayed on your app.py. Meg posted something. Yeah, could be. I'm not sure if memes are one of the categories in the ImageNet dataset. So yeah, it makes sense. Yeah, let's try something else. Let's go to browse files. And so I have 4 examples for you. Let's try to see this duck image. So I posted that duck image and the model is now classifying. It says duck, but now the prediction has changed. Since duck was not into the original 1,000 categories, but goose was there. So now you can say that the model knows that this is not exactly the duck animal, but something else very similar to the duck. Another example, we go to browse files again. Let's do a pizza. We go here and then the model again runs for some time. And no, it knows that it's a pizza, and with a very high probability of 0.89 that, but it's still showing 1% of French loaf and then others. It's for like, since there's like 1,000 possible values, it will show probability to each of them, but very, very less. But for pizza, it knows that, okay, this image looks like a pizza. Now for the last example, we will have a simple looking water bottle, and once the model processes it knows that it's a water bottle, and the probability has increased 0.97. So based on this, let's say you build, like based on any example, let's say for biomedical images, you wanna like classify, let's say you have a brain image, you wanna classify tumor or a non-tumor or a stroke or any other thing. You can build your own classifiers and have this demo so that people can test with your developed models. Okay, moving on. So before moving on, I hope everyone is reached till here. People just can give me a thumbs up. Cool. So next is we will look at this computer vision example, which is object detection. So now the problem has changed, and instead of saying that what's in the image or what class in the image, we want to see, okay, where is that object located inside the image. And once the model finds out that here's the image located, it tries to make a bounding box around it and say that, okay, this is the image. Like, so in the image, that's where the object is located. So this thing I did 3 years ago, I uploaded on my YouTube channel. And so let's take an example of what's object detection look like. And this was real-time object detection. I made this app and put it on my Android phone and just took a video capture and just using the camera. And this was in my home country, India, back in New Delhi. And once we run this, you can see what it means. So it's like all traffic video where a lot of activity is going on. There are buses, there are these small vehicles which carry the people, and there's like car and then buses, then there are pedestrians. So let me play it from again. Okay. Like you can see, this model is like running in real time, and then it classifies that, okay, there's a 98% probability that the lady in the image is a person, and then it identifies the traffic light, identifies the person, the car. So for the car in the front, it says the probability is 100, but for the car in the behind, they still have a very good probability. So you can assume that this kind of technology is being used in the self-driving cars where they know where's the traffic light and where's the traffic. And once we play it, like it just kinds of does it live. Yep. Yep. And now we're going to make our own. So for this demo, we will not do it on videos because it's it takes a lot of compute to do these kind of or deploy these apps. So we're going to look at a very small demo where we only have like what 90 classes to detect. So once you're ready, you can go to the next write for app.py and then run this. So once you run this thing, go here and then rerun. Yep. So now everything has changed. Instead of image classification, we are now in the object detection area, and the model is called faster RCNN. And now if we go to browse files, let's say we go to street and select this, it will first show you that this is the image you uploaded. So imagine there is a camera on this car, and now you're looking in the direction if you're moving, and now you want to classify or detect where are the things. So now the model has its output that it has detected there's a traffic light, which has a very high probability, like 100% it's showing that it's a traffic light. There are lots of cars, another traffic light here, lots of people, pedestrian, there's a bicycle here with a like more than 50% probability. So now these kinds of models can be deployed on self-driving cars or any other kind of thing to detect what's in the image, and based on that you can take some actions. So let's go through the code. So here what we have is I've defined all the labels. So this is what you need to convert the raw output from the model to the class label. Let's say the model predicts a higher probability for the first two classes, so, but it will just give you a number. So now you want to associate that number to an actual class so that you know whether it's a person or a bicycle or something else. And then you go, and this is a very important thing in Streamlit, that you have this catch resource command, so that every time you run it, you don't have to reload all the weights into the memory. Like once you run it, it will cache this into the memory, and you don't have to really do it again. And now again, what you do, you upload an image, it transforms that image into the model. The input required by the model processes it, converts it into an image, draws the boundary box, puts the label names, and if the score is more than 0.5, so what this means is that for each object detected, if the probability is more than 0.5, it will draw the rectangle and draw the text around it and say, okay, this is a person or a car. And if you want some more images, it's in the same folder. And I have four images. One start with this object detection: fruit, street, tennis, and zoo. So we'll look at each of them. But if you want to have just like some quick testing of this app, you can download it from there. Okay, let's go back here, and then let's go to browse files. And so we tested the street. Let's go to fruits and we'll load this. So now we have an image of a setup where we have a lot of fruits and plants at the background, and let's see what the model thinks. So just the model quickly identifies most of the things. It identifies a bowl and a vase. It says a potted plant in the background. Here it again says, although it sometimes misclassifies because probably orange is not in its training data, but now it says these small fruits are some kind of oranges. It doesn't have this fruit in its training data set, so it associates with a banana. So yeah, that's like one thing that if things are not in a training set, probably you will not see on your test. But overall, this probably gives you a very nice idea that because it identifies like a plate and a vase and a potted plant here. Yeah, let's try something. So let's go to a zoo image where we'll see different animals here. And now it's again, you can see in the right, it's running, and after it runs, yeah, it shows you an output that, okay, so it identifies zebra, but these rhinos are not in its data set, so now it misclassifies them as elephants. So that's one thing about this model, that you need to have all the classes in your training set first so that the model can identify it. For example, this is useful, and again, since I'm a student of biomedical engineering, I know more about biomedical applications. So let's say you have a tissue image where you see like healthy cells and cancer cells, and now you want to spot where are the cancer cells. So now you have to develop your own model based on these different kinds of cells and run it on. So that once you have a very good model, you can have like new images for it to explore and detect where are the cancer cells are located in that image. Okay, let's try another one. Um, okay, maybe I didn't upload the, let me check. Yep, this one. So I didn't put it there. I should download this. So that's how I can download this file and the images. Oh, it was there. Okay, it was there. Okay, sorry, fault again. Okay, that's fine. This is my local repo where I store all the images. And, object creation tennis. Yeah, that's here. And then if you go here again, I found this random image, and once the model processes it, it will say, okay, here's the player, here's your tennis racket, and then again players and a chair, and again players. And so this is how, if you have a really good idea of what's your problem is and have a some good amount of compute, you can do it real time, like I showed you in the video, where you can have you can record activities of the player, or you can have, so let's say this player wants to know when they have a forehand shot, how does the opponent respond. So based on this, you can generate good good analytics for like any kind of field. So in summary, I have put some examples here, which so first is like we saw, it's urban street scenes where there are busy streets, cars, bicycle, pedestrians, and then these can be used to show how object detection, like this kind of tech, can be used for autonomous driving or traffic monitoring. Second is sports event. Like in the tennis example, we can see how it can detect the tennis and racket. So you can do player tracking or more sports analytics. And in the zoo example, you can track animal movement to see how they behave. Okay, so any questions till now? Okay, in the chat. So guys, chat. Okay, how was the model processing the video you uploaded in the real time, but it takes so long on an image we upload here? Yeah, so the answer to this question is that probably you are running your Colab notebook on a CPU, because compute effects like so, and right now we are using it on transformers. This I'll show you it. So now it has this faster RCNN, which it's from Torch Vision, but the demo, the video which I showed, this runs YOLO V3. That was like 3 years ago, and it just runs on your native mobile. So like you can train your model on GPU, but then you can deploy it on a mobile device. So that's how it can run quickly. I hope this answers the question, because the main difference is in the compute you have right now. Because like my collab is linked to a T4, so if you want to run everything on GPU, you can go to here. runtime, change runtime type, and instead of your CPU, you can get a default GPU here. And then it will still run the notebook like what you have right now, but it's just that it will run it faster. And I think like every smartphone comes with a GPU these days, so you can have your app uh, deployed on a mobile device. Any other questions? If not, we will go to our uh, next example, which is emotion detection in text. So before that, we have to install this two packages so you guys can run the next cell. Yeah, and this problem is a multi-label classification problem that given a text, you have to say what kinds of emotions are there. So ideally this problem, so when they put the dataset out and they define 26 or 27 classes, but for this demo, I have restricted it to just like 7 classes. So once you have this model loaded, so you can run the next cell, which will download the model, which I posted on my Dropbox. Once the model is there, we can see what happens next. Okay. Please let me know if you have reached till this stage. Other people on Zoom, yes, Rachel, Vanshi. So once you have the model, the task for this model is that given a text, it should predict what are the emotions that present inside the text out of these 7 classes. So for example, let's say we have this example text. It says, thanks for a reply. I appreciate your input. Please keep me in the loop. So this text shows gratitude towards whoever this person is talking to. So once we run this and go back, it would say the source file is changed and we rerun this. Yeah, now instead of computer vision applications, now everything is changed. Now we are looking at emotion detection text using the BERT model. And let's say we uh, copy this text, put it here, enter. And we say, ask the model to analyze. Yep. So now once the model processes all the text, it shows that the model thinks that there are 3 possible emotions in the text, which is admiration, gratitude, and love here. And you can try whatever text you want to put. So I have given some examples here. So sample text, what you can try is, let's say, you can just copy this one, go back, paste, put analyze. So since we have a new text, ideally the probabilities of each class should change and it should detect what are the emotions present. So now again, so this text doesn't show any admiration, but now the model thinks it shows gratitude and love here because it probably looked at this love word and associated with this word with this class. And let's try another example. Let's say one others saying copy it, put it in your app. Once you run this, yeah, okay, let me know if you want to move to the next example. Yeah, yeah, also if you're having some issues, then please let me know. Okay, let's start with the next example. Now, instead of text processing, we would process audio and convert it to text. And this demo uses the OpenAI Whisper model. Uh, so first, let's install it. Yeah, so the first command installs the Whisper model, and then the FFmpeg is an encoder which is useful for converting your audio files to model readable file, and then once if there is this error, it's fine. It will still run. If it doesn't run, please let me know. But let's try this. So I have this small song example again on my drive. So you can try. So for more examples, once you go here and go to data engineering and then audio. So if you go audio, I have 3 sound examples. So the first one is a song, and then the other 2 are, I think somebody's reading a book or some other thing. Not a book. I think it's something else. Not- Yeah, let's go ahead and run this. Yeah, so now it goes to my Dropbox, loaded this image. And now once if you run this, you can like play whatever the song is. But yeah, so then yeah, just to check whether you have the right thing uploaded or not. Let's go here and run this audio to text converter. So once the cell is done running, we can go here, rerun it. Yep. And here it again asks for browse files. If I go here, browse files, and I put audio, and then let's say this one. I'll put this one, and then click on process. Yeah, and once the output comes, it shows you onto the text that, yeah, this is some text written by this guy in, probably he's reading, and this is the text. Yeah, now we can go try something else like the sound example, which I've shown here. So let's go, and then this is the sound example. So probably you think that instead of uh, just reading the text, it's probably easy, but this model is good that it can also detect text out of the songs, like the lyrics of this small part of a very long song. And then if I click on process, you can try to verify. That's why I put it here, that whatever the text you will see, you can play this song and see if it says this text here or not. Yep. And this is probably one of the easiest demo to make. And why I say this, because now like if you we will go through the code here, and And in this code, actually we are using this subprocess and OS Python packages to run this command line function whisper temp.mp3. So whatever audio you upload, it saves it as a temporary .mp3 file and then passes this command line. Whatever output comes in, it stores that output and shows on the screen. So earlier what we were doing, that we were just functioning like using everything in like functions from TensorFlow or anything else, but here we are just calling the command line function for whisper and getting the output. Yep. So this was all about Streamlit. Now if you for Gradio, so we go back here. Yeah, the second notebook here is Gradio demo. So for this, I only have one demo for right now, but I think I'll convert all the Streamlit demos to Gradio and update this notebook. So if you try to go through this tutorial again, you will probably find all the exercises in the Streamlit notebook in the same format as in Gradio. So if we go here and let's first kill this runtime. Once it's done, we can have this reconnect here. T4, I think like on a free collab account, you can get T4 for some time, so you can still use a GPU for prototyping your applications. Yeah, so yeah, let me know guys if you have opened this notebook here and onto the Gradio notebook for today's workshop. Please give a thumbs up so that I can know. People on Zoom, are you guys okay? Okay, now we can go. So for Gradio, I only have one demo, the emotion detection, because the like I tried, but the other demos didn't work. So let's go here and download the same model. Yeah. So again, here, once we have the model, the good thing about Gradio is that we don't really need to install any tunneling, or it will just, so it has functions built inside which will, so whatever you develop here, it will create a temporary link for you, and so that you can deploy your models. So let's run this. Again, what we do here is that we load the model, which we have downloaded it just now. And since we put some text, but the model doesn't understand text. So here we have to use this tokenizer to convert the text into numbers so that model can identify like what tokens are there or what words are there inside the text. And then we pass the text IDs to the model, we get the predictions, and since it's a multi-label classification problem, we get probabilities for each of the label. And now we define a Gradio interface where we show the text uh, onto the UI. Yes. Yeah, it's not in the repo. Yeah, I have to upload it. Okay. Yeah, it's just on Colab. Yeah. So once you have everything running, a good thing about Gradio is that you don't really have to open even open it in a new tab. You can just test things here. Yeah. So again, we go back to the original. Um, notebook and copy this. We go back to the Gradio demo, put it here, submit. It takes some time, and similar to the Streamlit demo, it will show you what are the classes, and it will give it in the like from the maximum to the minimum. Because in Streamlit, we saw that, okay, it was just defined in the order in which the labels appear, but in the Gradio demo, it just reorders them. Can try some more examples. Let's say this one. Which we didn't try. Now we submit again. Yeah. One last example. So now it just says it's 99% gratitude. Other classes are not present. So yeah, so that's all about today's workshop. If you have any questions, please let me know in the chat. Yeah, that's it for today, guys. Thanks for joining, and I hope to see you in the next workshop. So instead of all this model deployment or everything, we will actually start the actual data engineering in the next workshop on SQL. So yeah, that's it from my side.